Hello, good people. Here is the slope field for example number or question number 5 from 2008. Um, I went ahead and made a table where I was just using my x and my y coordinate at every of the 9 points and plugging them, substituting them into the dy dx equation, excuse me, so that I could get the slope and then draw a little line that had that slope. And this is what the slope field looked like. Part 2, or part B, we're supposed to find the particular solution to this differential equation, and we're supposed to use this initial condition. So I went ahead and separated the variables. I got to this point, and now I'm ready to take the antiderivative of each. So again, I multiply dx on both sides, that reduced the dx on the left side, and then I noticed there was a y minus 1, so I divided both sides by y minus 1, and that left me with this. I'm ready to take the antiderivative. Remember that 1 over x squared is x to the negative 2, so that when I take the antiderivative, when I integrate this side, it'll be x to the negative 1 over negative 1 plus c. On this side, 1 over y minus 1, really this is like a little u substitution where u is y minus 1, du is 1 dy, and then we just use the natural log antiderivative, and we're going to get the natural log of y minus 1, of the absolute value of y minus 1. This is x to negative 1 over negative, so this is really just negative 1 over x, and I'm ready to use my limit, not limit, use my initial condition to figure things out here. So I'm going to use this to figure out my c. So I'm going to do the natural log of my y minus 1 equals negative 1 over my x plus c. So this becomes positive 1 after the absolute values are applied, and I have the natural log of positive 1, which is 0, and that tells me that c has to be 1/2. Great, so I can replace this with 1/2. Now, where do I go from here? Well, we're trying to figure out the y equation, right? So the equation in terms of x, but as y equals something. So I'm going to take the e, I'm going to take this side, e to that side, and I'm going to take e to this side. So over here, these are going to undo each other, and I'm left with y minus 1. Let me go back to my black marker here. Y minus 1. On this side, I have e to the this plus that. Or remember that whenever we add exponents, that's the same thing as e to the negative 1 over x times e to the 1/2. I separated them into two pieces. And now we're going to take the absolute values away, which means this is going to involve a plus or minus e to the 1/2 times e to the negative 1x, 1 over x, 1 over x. And then I'm going to add the 1 over plus or minus e to the 1/2 times e to the negative 1 over x plus 1. Negative 1 over x. There you go. However, remember, I'm using this initial condition, and it's telling me that I should get 0, right? So if I substitute a 2 here, will I get 0? Well, I will if my, well, let's see. If I substitute a 2 here, I'll get e to the negative half times e to the positive half is going to give me e to the 0, which is 1. But if I want my y to be 0, this has to be negative, so I think this is what I need. So now when I substitute the 2 and I do all of this, my y is equal to 0, and it should satisfy this initial condition. I have my particular solution. And now we go for part C. Part C says, so all of this was part B, and now we go to part C. Part C says, take the limit as x approaches infinity of this function, negative e to the 1/2 times e to the negative 1 over x plus 1. Okay, so let's think about this. As I plug in big numbers in for x, this fraction is going to get closer and closer to 0. And if this fraction gets closer and closer to 0, e to the 0 will become 1. 1 times e to the negative 1/2 is negative e to the 1/2 plus 1. Or I guess I can put this, so you can write this that way, or 1 minus e to the 1/2, which is, by the way, just the square root of e. And this would be my answer for part C. Solving differential equations, especially in this course, whether it's A, B, or BC, really is all about finding, separating the variables, finding the integral of each side, and then solving for y. And then using an initial condition like we did in this pink box to find the constant of integration, the c value, and then we can solve for y and get to our final version of the particular solution. If you have questions on this problem, please bring them to class. We can talk about it. Otherwise, that's the end of this section where we talk about solving differential equations algebraically.